Hello everybody, this is Vainant from the Expert Box, and today we're going to talk about the world's most powerful word, if. We're going to do it using Minecraft, and I'm going to explain it from the basics, starting with the word false, because false is the basis of Boolean logic together with the word true. False is basically nothing. This light is not turning on because it's not powered. There's no power going to the light. It is false. When we compare this with an active piece of redstone block, it has power, it supplies power to the lamp, and it is thus true. Where that is false, this is true. False, true. So the light is on when it's true. In this case, we have an inverter that inverts the power from the redstone blocks to turn true into false, because it's inverted. It's the opposite of false. Not true is false. We then continue on and we replace the power source with a switch. So now it is false. That means the input is the same as the output. A equals to A, and if A is true, then the output is also true. So this is basically a straight conductor format. We take the same and we put it through an inverter with a switch. So A in this case is false, and the result is true because it's not A, not false, it's true. When we activate the switch, this light will go off. So the switch is currently off, we turn it on, and the light goes off because true, not true, is false. So this is the basis of inverters. We move on to the OR, and the OR is basically got two inputs that is joined together, and if either of them is powered, it will power the block because it conducts to the light. So either conductive route will give us the same effect as an OR. So we've got two inputs. This is B, and if B is on, the light is on because A or B will turn on the light. And if A is on, the light also goes on because A or B is true, and one of them is on. If both of them are on, it is still true because one of the two are on, both of them are on in this case. We're going to move on to the AND gate. We take it on, and this is two inverters from the inputs. That means that if both of them are off, then only will this block be powered off, which means this inverter on the bottom will then be on. So using three inverters, we can build an AND gate. In this case, it's A and B. So A and B, in this case both of them are off, so this will not be on. If we turn one of them on, the light will not go on. So you got B and A. If I turn on, now the light is still off because both needs to be on the inverter, and we have a result. Both of these gates are on. If either one of them are off, it will not be on. We can combine these ifs and ands, of course, like in any piece of electronic circuit. So in this case we have two AND gates connected together, wired together with redstone, and the intermediate result is some lamps. So basically it's two AND gates inputs combined together into an OR gate, and the result that we'll get from this is the A and B or C and D. I missed the D in the typo here. But basically it's A and B or C and D. First doing the ANDs and then the ORs. So in this case we turn on one, nothing happens. Two of these switches are on, so this OR gate is triggered that turns on the light. If we turn one of these other ones on, it will still stay on because one or one is true. So this gate still powers the gate in the other end. On the far end, you can see that the redstone lights up when it's powered. If I turn one of them off, the whole circuit will be powered off. So if A and B or C and D is true, the light goes on. So we can use this if statements basically through Boolean logic by creating a set of gates that will allow us to implement the word if. We can also build these gates vertically. That makes them stack easier for larger projects. Thank you for watching expertbox.com.